Good morning. My name is Carlos Parra. I'm a student of National Polytechnic School. I'm currently studying mechanical engineering, and here I'm going to show a beam medium uh, method that is used to uh, in create groups of machines. First of all, we need the distance matrix, which is given here, and the second input that we need is the number of groups that we need to create. Here we have the code. We have some for loops. The first of all uh, creates an assigns one machine to a group, creates the first group. If we create one group and if we have a distant matrix of 6 machines, and then it will mean that we will have just 5 groups. If we assign one machine to another machine, that would be the seed point. So we need to do as many assignments in order to get less and less groups until the groups are equal to the number of groups that the user required. Uh, yep, that's we have to find the minimum distance to assign a machine to a group. When we find the minimum distance, we find the machine to that group. At the end, we have the groups that were created, and here we assign the seed machine to the main machine, because in order to create these groups, the diagonal that is the machine 1 assigned to machine 1 has to be a high number, a high distance, so we don't have problems with this program. So we're going to test the program. We're going to run, and we're going to say that we need 2 groups. So here we have the groups. This column is the machines, and this is the second column is the seed points. So we can see here that machine 3 is assigned to machine 1, or seed point 1. Machine 4 is assigned to machine 1, machine 5 to machine 2, machine 6 to machine 2, machine 1 to machine 1, because that's obvious. And after that, we calculate the distance. In the distance matrix, we replace these positions and we got the distance. One interesting fact is that, for example, for this matrix, for these groups, we have to check if we change the seed point of the group. We have to check if the distance also changes. So for the first group, we have 1, 3, and 4. 1, 3, and 4. These are the machines. We have to check if we change the seed machine to machine 3 instead of machine 1, and recalculate the distance. If the distance is higher than the distance calculated before in the same group, that means that we have to keep machine 1 as the seed point. Otherwise, if the distance is smaller than in the group with the seed point of machine 1, that means that we have to change the seed point to machine 3. This happens in this exercise. In the second group, in the group of 2, 5, and 6, we have to change the seed point to machine 5, because if we maintain the seed point in machine 2, we have a total distance of 9. In group 1, we have a distance of 2, and in group 2, we have a distance of 7. But if we change the seed point to machine 5, we have a total distance of 8, which means that we have a distance in group 2 of 6 and the distance in group 1 remains the same. So we have to check that after we create the groups, but the groups will remain the same. So that's not that important at the end. Another interesting thing that we can see is that if we rerun the program and we get more groups, like 3 groups, the distance also decreases. And we can see here that after checking the seed points of the groups, we keep the distance in 5. We are going to run here we have the groups, like machine 3 is assigned to machine 1, machine 4 to machine 1, machine 5 to machine 2, machine 1 to machine 1, machine 2 to machine 2, and this is the new group that was created because we asked for one more group, that is machine 6 to machine 6. So our seed points will be 1, 2, 1, 2, and 6. Sorry. If we rerun the program and if we get 4 groups, the distance is 2 because we only have the group in which the seed point is 1. And in this group, for example, if the machine 2 is assigned to machine 2, the distance is 0, so we have a distance of 1, 1, 0, 0, 0, 0. So the total distance is 2. If we keep doing this, if we have 5 groups, we'll have a distance of 1, and if we have 6 groups, that would mean that machine 1 is assigned to machine 1, machine 4 is assigned to machine 4, machine 3 to machine 3, and so on. And the total distance will be 0. Thank you.